solutions from exercise 3.2 from the chapter Linear Equations. So in the first question, they're asking us to solve the following pairs of linear equations by the substitution method. So in the first question, the two given equations, the system of equations are x plus y is equal to 14 and x minus y is equal to 4. So in the substitution method, you're going to express one variable in the terms of another variable, and you're going to substitute the variable in the terms of another variable in another equation, so that you only have to find the value for one variable, and once you find the solution for that variable, you're going to substitute that value in either one of the equations in order to find the solution for the other variable. So we're going to express x in the term of y. So we're going to express the first system of equations in the terms of y. So x would equal 14 minus y. And we're going to substitute the value of x in the terms of y in this equation in order to find the value of y. And once we find the value of y, we're going to find the value of x. So substituting the value of x, which is 14 minus y, in this equation, you would get 14 minus y is equal to 4. And 14 minus 2y is equal to 4. And minus 2y is equal to minus 10. So y would equal 5. So you're going to substitute the value of y, which we got, in either one of the equations. So for example, in this case, we'll substitute it in the first equation. So x plus 5 is equal to 14. So x is equal to 14 minus 5. And 14 minus 5 is equal to 9. So the value of y is 5 and the value of x is 9. In the second question, the given system of equations are s minus t is equal to 3 and s by 3 plus t by 2 is equal to 6. So in the second equation, we'll notice that it is in a fraction form, so it'll be much easier to solve if we cancel the denominator. So in order to do that, we're going to cross multiply, get the same denominator, and then bring this over to this side. So when we cross multiply, get 2s plus 3t by 6, which is equal to 6. So you'll get 2s plus 3t is equal to 36, which is the second equation. So in this case, let's write s in the forms of t. So you'll get s is equal to 3 plus t from the first equation. And we're going to substitute this value in this equation in order to find the value of t. So when we do that, we're going to get 2 times s value is 3 plus t, so 3 plus t plus 3t, which is equal to 36. 6 plus 2t plus 3t is equal to 36. So 2t plus 3t is 5t, and 36 minus 6 is 30. So t is equal to 6. So now since we got the value of t, we're going to substitute it in the first equation. We can substitute it in any equation, but in this case, let's substitute it in the first equation. So s minus 6 is equal to 3, and s would equal 9. So the value of t is 6, and the value of s is 9. In the third question, the given system of equations are 3x minus y is equal to 3 and 9x minus 3y is equal to 9. So in the second equation, we'll notice that all of the terms can be cancelled out by 3. So we can simplify the second equation, and we can write that as 3x minus y is equal to 3. So we will notice that we know that if a1 by a2 is equal to b1 by b2, and if it's equal to c1 by c2, then the given system of equations will have infinite number of solutions, and on a graph it'll represent a coincident line. So that means these two equations can have infinite number of solutions. So the answer to this equation would be when we rewrite the first equation in the terms of y. So when we write the first equation in the terms of y, we would get minus y is equal to 3 minus 3x, and y would equal 3x minus 3, which is the answer, and where we can take the value of x as any number, because both of these equations have infinite solutions. In the fourth question, the given system of equations is 0.2x plus 0.3y is equal to 1.3, and 0.4x plus 0.5y is equal to 2.3. We'll notice that all of these are in decimal, so in order to get them as a whole number, we can multiply both of these equations by 10, and they'll still be equal because we're multiplying both sides of the equation. So when you multiply the first equation by 10, you'll get 2x plus 3y is equal to 13, and the second equation can be written as 4x plus 5y is equal to 23. Now we're going to write y in the form of x. So when we write y in the form of x, you would get 3y is equal to 13 minus 2x, and y is equal to 13 minus 2x by 3. Now we're going to substitute the value of y in the second equation. So we would get 4x plus 5 times 13 minus 2x by 3 is equal to 23. And 4x plus 5 times 13, which is 65, minus 10x by 3 is equal to 23. And in order to make sure that 4x also has a common denominator 3, we're going to multiply 4x by 1 times 3 on both the numerator and the denominator. So you'll get 12x plus 65 minus 10x is equal to 23 times 3, as we're bringing 3 over to the right hand side. So you'll get 12x plus 65 minus 10x is equal to 69. And we're going to bring 69 over to this. We're going to bring 65 over to this side. So 12x minus 10x will give us 2x, and 69 minus 65 will give us 4. And when we bring 2 over to this side, we can isolate the x, so x will equal 2. So now we're going to substitute the value of x, which we found in either the first equation or the second equation. So in this case, we'll substitute it in the first equation, which is 2x plus 3y is equal to 13. Since the value of x is 2, we'll get 4 plus 3y is equal to 13. And we're going to isolate 3y. We're going to bring 4 over to the side. So 13 minus 4 would give us 9. And y is equal to 9 over 3. So y is equal to 3. So the value of x is equal to 2, and the value of y is equal to 3. In the fifth question, the given system of equations are root 2x plus root 3y is equal to 0, and root 3x minus root 8y is equal to 0. So first we're going to represent y. We're going to express the variable y in terms of x. So if we write the first equation in the terms of y, we would get root 3y is equal to negative root 2x, and isolating the y, we'll get negative root 2x over root 3. So we're going to substitute the value of y expressed in the terms of x in the second equation. So it would be root 3x minus root 8 times negative root 2x by root 3. So is equal to 0. And root 3x minus root 8 times minus root 2x would give us positive root 16 over root 3, which is equal to 0. And we know that root 16 is 4, so root 3x plus 4 by root 3 is equal to 0. In order to make sure that both of these terms have the same common denominator, we're going to multiply both of them by root 3. So multiply both the numerator and the denominator by root 3. So when we do that, you'll get 3x plus 4x by root 3, which is equal to 0. And 3x plus 4x will give us 7x, and root 3, when it goes over to this side, becomes 0. So x is equal to 0. Now we're going to substitute the value of x is equal to 0 in the second equation. So when we do that, you would get root 3x times 0, which is 0, minus root 8y, which is equal to 0. 0 times root 3 is 0, minus root 8y is equal to 0, and y is equal to 0 divided by negative root 8, and 0 divided by any number is equal to 0, so y is equal to 0. In the sixth question, the given system of equations are 3x by 2 minus 5y by 3 is equal to negative 2, and x by 3 plus y by 2 is equal to 13 by 6. Since both of the equations are in fractions, it'll be much easier if we cancel the denominator. So the first equation can be written as 9x minus 10y by 6, which is equal to negative 2, and 9x minus 10y is equal to negative 12. And the second equation can be written as 2x plus 3y by 6 is equal to 13 by 6, and 2x plus 3y is equal to 13, because 6 times 6, 6 and 6 would get cancelled. So the two final equations that we would get would be 9x minus 10y is equal to negative 12, and 2x plus 3y is equal to 13. And in the first equation, we're going to represent x in the terms of y. So we can say 9x is equal to negative 12 plus 10y. X is equal to 10y minus 12 over 9. We're going to substitute the value of x in the second equation. So 2 times 10y minus 12 by 9 plus 3y is equal to 13. 20y minus 24 by 9 plus 3y is equal to 13. In order to make sure they both have the common denominator, we're going to multiply 3y, both the numerator and the denominator, by 9. So you'll get 20y minus 24 plus 27y is equal to 13 times 9, because we're bringing 9, the common denominator, over to the right hand side. So 20y plus 27y is 47y is equal to 9 3s are 27, 9 1s are 9, 117 plus 24. And when we add 117 plus 24, you will get 47y is equal to 141, and y is equal to 3. We're going to substitute the value of 3 in the second equation. So 2x plus 3y is equal to 13. 2x plus 9 is equal to 13. 2x is equal to 13 minus 9. 2x is equal to 4, x is equal to 2. So the value of x is equal to 2 and the value of y is equal to 3. In the second question, they're asking us to solve 2x plus 3y is equal to 11 and 2x minus 4y is equal to negative 24, and hence we need to find the value of m for which y is equal to mx plus 3. So first we need to find the values of x and y. We're going to substitute that in this equation to find the value of m. So the first equation is 2x plus 3y is equal to 11 and 2x minus 4y is equal to negative 24. Well, let's express 3y in the terms of 11 minus 2x, where y is equal to 11 minus 2x over 3. We're going to substitute the values of y in the second equation. So you will get 2x minus 4 times 11 minus 2x by 3, which is equal to negative 24. And 2x minus 44 plus 8x over 3 is equal to negative 24. 6x minus 44 plus 8x is equal to negative 24 times 3. 6x minus 44 plus 8x is equal to negative 72. 6x plus 8x will give us 14x, which is equal to negative 72 plus 44. So 14x is equal to negative 28, and the value of x is equal to negative 2. We're going to substitute the value of x in the first equation, which is 2x plus 3y is equal to 11. So negative 4 plus 3y is equal to 11. 3y is equal to 11 plus 4, which is 15. So y is equal to 5. So substituting that in y is equal to mx plus 3, we would get 5 is equal to m times negative 2 plus 3. So 5 is equal to negative 2m plus 3, and 2 is equal to negative 2m, and m is equal to negative 1. In the third question, they're asking us to form the pair of linear equations for the following problems and find their solution by the substitution method. So the first question, they've said that the difference between two numbers is 26 and one number is 3 times the other, and we need to find both of the terms. So let us assume the first number is x and the second number is y. So the difference between them, x minus y, is 26, and one number is greater than the other number. So since we're finding the difference between the two numbers, that means x is definitely bigger than y, because x minus y is 26. So that means x is the biggest number out of the both of them. So x is 3 times the other number. So x is equal to 3y. And we need to find both of them using the substitution method. So since x is already expressed in the terms of y, we're going to substitute the value of x in terms of y in the first equation. So you will get 3y minus y is equal to 26, and 2y is equal to 26, and y is equal to 13. Substituting this value in the second equation, we would get x is equal to 3 times 13, and x is equal to 39. So the value of x is 39 and the value of y is 3. So the first number is 39 and the second number is 13. In the second equation, they've said that the larger of two supplementary angles exceeds the smaller by 18 degrees. We need to find them. So we know that supplementary angles are angles that add up to 180 degrees. Assuming that the first angle is x and the second angle is y, x plus y is equal to 180 degrees, which is the second equation. And they've said that the larger of the two supplementary angles exceeds the smaller by 18 degrees. So if x is the largest angle, then the smallest angle exceeds the largest angle x exceeds y by 18 degrees. So this would be the first equation. So x is equal to 18 plus y, and x plus y is equal to 18. And since x is already expressed in the terms of y, we're going to substitute the value of x in the second equation. So 18 plus y is equal to 180 degrees, and 18 plus 2y is equal to 180 degrees. 2y is equal to 180 minus 18 degrees, and 2y is equal to 162. Y is equal to 162 divided by 2, which is 81. And we know that x plus 81 degrees is equal to 180. So x is equal to 180 minus 81, and the value of x is equal to 99 degrees. And y is equal to 81 degrees. In the third question, they've given that the coach of a cricket team buys 7 bats and 7 balls for 3,800. Later, he buys 3 bats and 5 balls for 1,750. We need to find the cost of each bat and each ball. So we know that the total cost for buying a bat is the number of bats bought times the cost of 1 bat. So he said that in the first case, the coach buys 7 bats for the cost of X rupees per bat. So the total cost of buying 7 bats would be 7x. Similarly, he buys 6 balls for the price of 1 ball being y. So the total cost of the 6 balls he bought would be 6 times y, so 6y. So the total cost of buying both the bats and the balls would be 7x plus 6y, which is equal to 3,800. Similarly, he buys 3 bats and 5 balls for the cost of 1,750. We need to find the value of x and y. So in the first equation, we're going to express y in the terms of x. So it would be 6y is equal to 3,800 minus 7x, and y is equal to 38,000 minus 7x by 6. And we're going to substitute the value of y in the second equation. So we would get 3x plus 5 times 3,800 minus 7x by 6 is equal to 1,750. So 3x plus 19,000 minus 35x over 6 is equal to 1,750, and 18x plus 19,000 minus 35x is equal to 1,750 times 6. 18x minus 35x will give us minus 17x plus 19,000, which is equal to 1,750 times 6. And we're going to multiply both sides of the equation by negative, which would give us 17x minus 19,000 is equal to negative 17,500, 1,750 times 6, and 17x is equal to 19,000 minus 1,750 times 6 is 10,500. So 17x is equal to 8,500, and x is equal to 8,500 divided by 17, which is equal to 500. We're going to substitute this in the second equation. So we would get 3 times 500 plus 5y is equal to 17,750. 15,000 is equal to 5 plus 5y is equal to 1,750. 5y is equal to 250 and y is equal to 50 rupees. So the value of y is 50 and the value of x is 500 rupees. In the fourth question, they've given that the taxi in a city consists of a fixed charge together with the charge for the distance covered. For a distance of 10 kilometers, the charge paid is 105 rupees, and for a journey of 15 kilometers, the charge paid is 155 rupees. What are the fixed charges and the charge per kilometer? How much does a person have to pay for traveling 25 kilometers? So we're going to assume that the fixed charge should be x and the charge for each kilometer be y. They've given that for a distance of 10 kilometers, the total cost paid is 105 rupees. So the total cost paid is the fixed charge plus the cost per kilometer. So the fixed charge is x, and the charge per kilometer, which is 10 kilometers, is 10y, is equal to 105. Similarly, the cost paid for 15 kilometers is 155. So that would be x plus 15y, which is equal to 155. So we're going to express y in the terms of x. So y is equal to 105 minus x by 10. So we're going to substitute this value in the second equation. So we would get x plus 15 times 105 minus x by 10, which is equal to 155. So 15 and 10 can be cancelled. So we would be left with x plus minus 3x by 2, which is equal to 155, and 2x plus 315 minus 3x is equal to 155 times 2. So 2x plus 315 minus 3x is equal to 310. 2x minus 3x would give us minus x, and 310 minus 315 will give us negative 5, so the value of x is 5. Let us substitute the value of x in the first equation. So we would get 5 plus 10y is equal to 105. 10y is equal to 100, and the value of y is 10. And they're asking us to find the cost for traveling a distance of 25 kilometers. So the cost of traveling 25 kilometers is the fixed charge, which is x, plus 25 kilometers times the cost per kilometer, which is 10. So 5 plus 250 would be 255 rupees per 25 kilometers. In the fifth question, they're given that a fraction becomes 9 by 11 if 2 is added to both the numerator and the denominator. If x is added to both the numerator and the denominator, it becomes 5 by 6. We need to find the fraction. So let us assume that the numerator is x and the denominator is y. So when 2 is added to both the numerator and the denominator, you get 9 by 11, and when you add 3 to the numerator and the denominator, you get 5 by 6. So we're going to simplify both of these equations by cross multiplication. So when we do that, you would get 11x plus 22 is equal to 9y plus 18, and 11x minus 9y is equal to 18 minus 22, which is negative 4. So 11x minus 9y plus 4 is equal to 0 would be the first simplified equation. The second equation can be written as 6x plus 18 is equal to 5y plus 15. 6x minus 5y is equal to 15 minus 18, which is negative 3, and 6x minus 5y plus 3 is equal to 0. So we're going to express y in the terms of x. The second equation, we're going to express the value of y in terms of x. So we would get negative 5y is equal to negative 3 minus 6x. Multiplying by negative on both sides, you would get 5y is equal to 3 plus 6x. So y is equal to 3 plus 6x by 5. So we're going to substitute this in the first equation. So when we do that, we would get 11x minus 9 times 3 plus 6x over 5 plus 4, which is equal to 0. You will get 11x minus 27 minus 54x by 5, which is plus 4, which is equal to 0. And in order to ensure that they both have the same denominator, we're going to multiply both the numerator and the denominator by 5. So you'll get 55x minus 27 minus 54x plus 20, which is equal to 0. When we simplify this, you will get x minus 7 is equal to 0, and x would be equal to 7. So we're going to substitute the value of x, which is equal to 7, in the first equation. So when we do that, we would get 11 times 7, which is x minus 9y, plus 4, which is equal to 0. So 77 minus 9y plus 4 is equal to 0. Minus 9y is equal to negative 81, and y is equal to 81 over 9, and both the minus signs get cancelled, so you will be left with 9 as the value of y. So the fraction would be 7 by 9 as so the fraction is equal to x comma y, and since the value of x is 7 and the value of y is 9, the fraction would be 7 by 9. In the fifth question, they've given that 5 years hence, the age of Jacob will be 3 times that of his son. 5 years ago, Jacob's age was 7 times that of his son. We need to find their present ages. So let us assume the age of Jacob to be x and the age of his son to be y. 5 years from now, their ages would be 5 plus x and 5 plus y. So they've said that 5 years from now, Jacob's age, which is x plus 5, would be 3 times that of his son, which is y plus 5. So x plus 5 is equal to 3y plus 15, and x minus 3y is equal to 10, which is the first equation. Secondly, 5 years hence, 5 years ago, meaning their ages were x minus 5 and y minus 5. So x minus 5, Jacob's age is said to be 7 times his son's age, which is y minus 5. So x minus 5 is equal to 7y minus 35, and x minus 7y is equal to minus 30. So we're going to take this as a second equation. We're going to express x in the terms of y. So x is equal to 10 plus 3y. And we're going to substitute this in the second equation. So when we do that, we would get 10 plus 3y minus 7y is equal to negative 30. And negative 4y is equal to negative 40. Y is equal to 10. And now that we found the value of y, we're going to substitute that in the second equation again. So we would get x minus 70 is equal to negative 30, and x is equal to 40. So Jacob's age is 40 years old, and his son's age is 10 years old.